Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good day to Chairperson TS Dr. Nur Ashikin, the Environ 2021 Committee, and to all researchers and audience. I'm Nurfaiza binti Bawadi. We'll present regarding to our research entitled Prediction of Soil Settlement using Numerical Modeling based on shear wave velocity measurement. As an introduction, there are few questionable remarks in our research, which is, how can geophysical method survive against the conventional methods? Alright, the geophysical method is a seismic method that considered as a non-destructive geotechnical technique to determine the soil profile based on the shear wave velocity profile. The shear wave velocity was found to be directly proportional to the strength of the soil. It's proved by previous study that close relationship between conventional method and seismic method such as SPT and CPT tests. The second question is how to use the potential seismic wave in soil exploration. The potential seismic wave that propagates in the soil medium will be extrapolated in the term of shear wave velocity using software analysis, which is the function and the consideration of shear wave velocity profile will be used same like n value from SPT test in determine the strength of the soil. The last question is, are there any innovations that can be applied to the soil exploration? Yes, by consideration of wave propagate in the soil medium, there are few equipment has been developed in geotechnical field such as spectral analysis surface wave SASW, multi-analysis surface wave MASW, resistivity, and etc. Generally, the conventional ground explorations involve several issues regarding the process of drilling, boring, sampling, in situ testing, and also the lab testing. These methods are considered as localized, costly, and time-consuming. The cost also can be very expensive if more of tests required to be conducted to characterize the ground in details. On the other hand, the process of sample collections, sample preparation for lab tests may affect the originality of soil properties. It's considered as disturbed sample. This reason may cause inaccuracy of soil properties, indirectly affect the design process. So, in this research, the development of Plaxis model has been validated the efficiency and reliability of shear wave velocity in prediction of soil settlement. This study aimed to explore the prediction of soil settlement using Plaxis software based on SASW data measurement. There are three objectives that has been achieved to fulfill this research target. There are to determine the relationship of soil profile between conventional and SASW methods, to predict the soil settlement using empirical analysis based on n value and shear wave velocity value. The last one is to develop the numerical model using Plaxis software in determining the soil settlement by consideration of n value and shear wave velocity value. As mentioned before, the concept of geophysical method is based on seismic wave that propagate in the soil medium. The seismic wave can be categorized into two types, which is we have a surface wave here and also the body wave. As shown here, there is the location of the wave in the soil medium. How we differentiate with this type of wave in terms of particle motion? Okay, for primary wave, okay, there is the primary wave, or we consider is a longitudinal. The particle motion consists of alternating compression and dilation parallel to the direction of propagation in longitudinal directions. For secondary wave, particle motion consists of alternating transverse motion perpendicular to the direction of propagation, means that in transverse direction. Meanwhile, the particle motion for Rayleigh wave consists of elliptical motion, basically in retrograde elliptical in the vertical plane and parallel to the direction of propagation. The amplitude will decrease with the depth. As you can see in this slide, here is the explanation on how researchers extrapolate the wave propagate in the soil medium as a soil properties. The wave propagate will catch up by the geophone as a wavelength. Okay? By considering the frequency and the wavelength, it will transform to velocity using this equation. This velocity will be used to analyze the soil profile. Here is the overall flow of these research activities. It can be divided to 3 phases, which is SASW field testing, empirical analysis, and also the numerical analysis. In the first phase, it has been performed to obtain the first objective of this research. There are 2 activities involved, which is interpretation secondary data from the SI report and the primary data collection by performing SASW field testing. The data analysis has been performed by using wind source software, and the outcome of this phase are to develop the soil profile based on N value and also shear wave velocity value. The second phase involves the process of empirical analysis. The N value has been used in manual calculation based on empirical equation that has been developed by Vesic, Paulus, and Bowles. Meanwhile, the equation that has been developed by Kachali has been used to determine the soil settlement by considering the shear wave velocity value. The third phase are the numerical analysis. In this phase, the numerical modeling has been developed using Plaxis Software by consider the N value and shear wave velocity value in performing the model and analysis. As shown in this slide, it shows the general procedure and arrangement of SASW field testing. The field measurement were conducted using a seismograph. We call this one is seismograph, and 2 numbers of geophone. Minimum is 2 numbers of geophone with 1 Hz natural frequency and 400 volt per meter per second calibration factor. The configuration of field measurement was set up using common array profiling. This is how the wave propagate in the soil medium, as you can see here. Okay, and how it looks like in our software. The determination of shear wave velocity is based on 3 stage category in data interpretations and analyzing using wind source software. This study was focused on 3 compartments, which were data interpretations and analysis in wind source, empirical computation of soil settlement value, and the development of numerical modeling performed by Plaxis Software. As shown here, it represents the relationship between N value and VS value. Based on the pattern profile inside 1, there were few intersection points between both data, which was exhibiting a high similarity between both data, especially at depth 1 meter, 3 meter, and 6 meter. 1 meter here, 3 meter here, and 6 meter. For the graph side 2 and side 3, both graphs were shown the increasing trend line with the n value were increasing with them. However, the correlated n value proposed by Jeffrey, considering the shear wave velocity, would seem to be slightly overestimated compared to n value. In this research, the prediction of soil settlement was determined by an equation that developed by several researchers based on bearing capacity. From the n value, we calculate to get the bearing capacity, and from the bearing capacity, we calculate to determine the settlement. The result shows that the settlement that calculate based on n value to determine the bearing capacity are much greater than the result they obtained from the shear wave velocity considerations, where the basic method had the highest polar-bipolar bold and Kirchhoff for the whole site. This slide shows the comparison of soil settlement between empirical calculations and also the numerical modeling using Plaxis software. The result of Kirchhoff methods are the nearest to the Plaxis software, where the percentage difference between these two methods less than 25% difference. By comparing soil settlement value, calculate based on consideration of bearing capacity. The soil settlement value was relatively large. In general, this condition is due to the concept of seismic method, which is it involves the spread of geometry of shear wave in 2D direction, vertical and horizontal in soil strata, while the conventional technique, SPT and also the CPT conduct, it focuses only in one point direction, vertically, based on the selected borehole. As a conclusion, the shear wave velocity profile had a close relationship with the n value, and properties of soil proportional increase with the depth as n value performed. The correlation of n value and shear wave velocity could be used for the prediction of soil settlement. The prediction of soil settlement based on SASW measurement by Kirchhoff was more conservative than conventional method. The SASW is valuable for further researching towards the prediction of soil settlement in the geotechnical engineering. Okay, that's all from me. For further explanations or any inquiry, feel free to contact me through this email address. Thanks for your time and have a good day. Thank you.